Okay, good morning, everybody. Now, do you remember what we were talking about last time? What is it that we were talking about last time? Functions. So we were talking about functions, right? We were talking about different ways to define functions, and we talked about the concept of a closure. Do you remember what a closure is? No? It's right there. So when we define an inner function and then try to execute or access this function from outside of its context, for example, if we define an inner function from another function and then return it, then that function comes with the enclosing context. All right, so after the function was executed, for here, for example, we had a function that's called raise power that has an inner function that's called power helper, right? Now, when we define when we executed the raise power with a value 2 or with power 2, a context was created for that raise power with power equal 2, right? And then within that context, can you hear me? Can you hear me in the back? Can you hear me here? No? Okay, I'm just gonna change the. All right, let's see. Okay, so when we were defining this, maybe we should see it in action. So let me see if I still have it. Okay, so here we defined an inner function that's called power helper, right? And eventually we return that power helper from the raised power, okay? So when we do this call, you see, when we use the parentheses, we call the function for execution. So raised power would be executed, and then the power helper would be defined within that execution context when power was equal to 2, and then it will be returned. So now this pointer would be pointing at the power helper definition that was created when power was equal to 2. Okay? Now, when we call it again here, raised to power with power equal 3, it would be executed and it would return another definition for power helper that was created when power was equal to 3. So when we try to execute that power helper definition, when it was created with power equal to 2, it will always see that power was equal to 2. It will remember that there was something called power, and that power was equal to 2. Here, when we try to execute that definition of power helper, it will remember that there was something called power, and when it was defined, that power was equal to 3. Okay, so when we return a function, an inner function, it doesn't come by itself. It comes with the surrounding context. All right, so that's what we call the closure. There's another thing that you might not be exactly familiar with from Java. It's not exactly, when in Java they try to resemble it a little bit, but it's not exactly the same. But that is that you can send a function as a parameter. Remember what is the parameter? A parameter is a variable that we defined with the function to receive an argument, right? So the value that we send to the function is the argument. So now here we are defining a function called apply, and it takes what we call the callback function. So this is just a parameter that receives any value, right? Now we are planning to receive a function in that parameter. And then there is another parameter called value. So here this is a very generic function that takes any other function and apply to any other value. So you see here, I can call it to apply and then send the function. Now remember, when we use the function name without parentheses, we're not calling it for execution, right? This is just a pointer to the function object. Okay? And here we can send it another function. It's call it the other cubic function, and then we send it to apply to on 5. Okay? So that's what we call the behavior parameterization. So we treat the behavior, we treat the code as a parameter that we send to the function. So the same function can apply different behavior depending on what we send it. Okay, so here's a more meaningful example. So let's say we have some scores. Okay, and we want to filter these scores based on some sort of a predicate. Okay, so we would loop over the scores. So these are the result of the filtered, and we would loop over the score and apply the predicate on the score. And if it returns true, then we append it to filter. If it doesn't, then we ignore it. Okay. Now we can apply different predicates at different times. So here we are applying the above threshold predicate, and here we are applying range predicate. Okay, let's take this example step by step. So we have some scores. Equals, so I'm just gonna put some random values. Doesn't have to be. Okay, now we have a function that would filter scores. Okay, now let's start with no predicate. It just takes the scores and filter them. Okay, I'm just gonna apply it on the global variable scores here. Okay, you can always define a local variable for it. Okay, now if I just want to filter, so let's say filtered is equal, right now is empty. So I just want to filter this, the scores based on some criteria. For at the beginning, the criteria was fixed to say I wanted all scores above 7. Okay, so in that case, I would need to loop over the scores, right? And if the score above 7, I will append it to the filtered. Okay, and then we return filtered. All right, so at this moment, it's just a very basic function with simple loop and simple condition. If the score matches the condition, we return it, otherwise we ignore it. And then I'm gonna print the filtered. Sorry, I'm gonna return the result of the filter scores. And I want to call this function for execution, so I have to follow it with parentheses. Okay, so it should be simple. We should know exactly what we expect. All the scores that are above 7 is what returns. Now, later on, we happen to change our minds and we want to filter them based on another condition. So maybe we just want a range of scores between 5 and 7. So what would we do? Yes. Yeah, so we either create another complete function with repeat the entire code except for the condition, or change this function and lose the old condition altogether. So what if we want to keep the ability to apply the above 7 condition and the range condition? Both of them are needed in different locations. And it is a very, very bad practice to repeat your code. So it's like in software design, there's a specific rule that says do not repeat yourself. Do not duplicate your code. Okay, duplicating code is problematic. We don't want to do that. So it's definitely, there's a possible solution that I create another function with just one very simple change that is a condition here. It is possible, we solve the problem, but it is a very bad design. Okay, so instead, we want the ability to change the behavior. Okay, so this is just not a value. You remember when we used a parameter here? We used the parameter, so let's say when we said add A and B, and then return A plus B. Why did we do that? So if I want to add 5 and 7, why didn't I just add 5 and 7? Why did I use a variable for it? Because sometimes I want to add 5 and 7, sometimes I want to add 10 to 10, sometimes I want to add 3 to 4. So I'm using a parameter to allow for variability of values, right? Now we can also use a parameter to allow for variability in behavior as well, not just value. So when we say 5 versus 7 versus 3, this is a basic value. We can also use a parameter like this in order to allow for change in behavior. Okay, so I can receive something here, and it's very easy in Python because it's weakly typed. So the variable is just a name here. I just know that this predicate function, this is a general type of functions that takes a value and returns true or false. Okay, so I expect here a predicate function that is a function that takes a value and returns true or false. And instead of writing the condition here, I'm just gonna apply this function on my value. Okay,